Hey, what's up, dudes? Alright. Just set our timer here. And what did we do yesterday? So yesterday we did reconnect logic in server part 5. We were working on code to reconnect the client to the proper game worked in server file. Spent mostly the entire session learning about how to implement hash tokens for secure verification via ChatGPT. We stopped at line 317 in server. Alright. So today we're going to be continuing working on that code. We're going to focus on implemented the token verification code in server 5. Network.pypy. Like, you ever just wake up from a nap and you're like aggravated? I don't know, man. I woke up from a nap and I was just pissed off. I don't really know why. I don't know. In a weird mood. In a mood. Sometimes you get in a mood. I don't know why. This makes sense. There we go. Audio works. Cool. Alright, so we had stopped here. And, is this too loud? Is that... Let me see real quick if this is too loud. Alright, so we had stopped here. And, is this too loud? Is that... Let me see real quick if this is too loud. It's a little bit loud. I'll lower it just a little bit. There we go. Okay. Alright, so back to it. So we stopped here. Next is add code, which generates a secure client token and includes it in the below initial send. See token pi for code generated by ChatGPT for this process. Review code and include what is necessary and double check everything. Okay, so let's open that up, token, and I don't know, maybe we'll.
You're about to find out what it's like to find a reef.
Maybe we should keep it in its own file. I don't know. It might make sense. So we have importing HMAC, importing hashlib, importing base64 in JSON. HMAC, hashlib, base64. Let me get a little very quick refresher on what those are. I learned about them, but I just like to do that. Like, I know generally what they are, but let's see. likely referring to how HMAC, hashlib, and base64 are commonly used together in Python, typically used to sign, verify, or securely encode data. Here's a quick explanation of each any practical example. HMAC is used for creating keyed hash message authentication codes. Keyed hash message authentication codes helps verify that a message hasn't been tampered with. Hashlib provides access to cryptographic hashing functions like SHA-256. Base64 encodes binary data to printable ASCII or decodes it, often used for transmitting binary data over text-based protocols. Gotcha. Okay. And why does this show... report shadowed imports is overriding the standard lib module token. Why is it HMAC? You must HMAC. Okay. So there's a standard library module. There's a module in Python library called token. Okay, gotcha. We'll rename it to hash token. Ooh, I see. There we go. That was confusing. A little bit. That was a little bit confusing. Alright, now we got our secret key here. And we'll make it be... Well, it could just be some random thing, right? It doesn't really need to be anything particular. There we go. Alright, that's our secret key. And now we have the... def generate token, which takes in the match ID and the player ID. We create the payload as a dictionary, match ID to match ID, player ID to player ID. Very straightforward here. Then we have payload JSON is equal to JSON dumps. And I really want to rewrite this because that's just how I like to do. If I ever copy code, I really like to write it out myself. So what we're gonna do is we're gonna create this in main, and it's gonna be called. Why is this showing? Well, first. We'll save this as hash token GPT. And then this will be hash token. Hash token. There we go. Alright, now we're going to put them side by side. And I will look at it like this. Alright, now we're going to type it out. Because that's like, you know, that's really how you learn, right? Import hmac, hashlib, base64, and JSON. And then we're going to create our secret key, which is going to be a bytes version of this string, and we're just going to make it JMT3BAOTP. That's Jedi Mind Tricks, Third Eye Blind, Army of the Pharaohs. It's just some, it's like an old username I used to use a long time ago type thing. So anyway, def generate token is going to take match ID, player ID. It's going to have the payload, which is equal to match ID. Match ID, then we have comma. We're going to have, well, we call it game ID. And then this is going to be the client ID. So this is going to change to game ID. Alright. Now we have our payload JSON, which is equal to JSON dumps, taking in payload. And separators are used to shorten it. And then we're going to encode that. So this converts it to a JSON string, and then we encode it into UTF-8 bytes. Now we have signature, which is equal to hmac.new. I'm just going to take in the secret key. It's going to take in payload JSON, hashlib.sha256. So it takes in the key, the payload JSON, and then the hash method. And then we say dot hex digest, and that returns a string of hexadecimal digits. And hexadecimal is A through F and 0 through 9. Right? I believe. Converts resulting hash into a readable hexadecimal string. Okay, no, I'm wrong with that. Hexadecimal string. Hexadecimal is 64 characters. So it converts from 256 bits to 64 characters. So hexadecimal does use 0 through 9, A through F. Each hex character equals 4 bits. So hex is a compact way of representing binary data. Hexadecimal converts 256 bits into 64 characters. Shot TV. Converts those 32 bytes into 64 hex characters. 1 byte equals 8 bits. 1 byte equals 2 hex characters. Gotcha. Okay, so it does do 0 through 9, A through F. I did have that right. SHA-256 is a hash method. It's a hash method. It's a cryptographic hash function. SHA stands for Secure Hash Algorithm. 256 produces 256 bit or 32 byte output. Okay, I see. So there's our signature, which includes the exact payload. And then we have our token, which is base64.urlsafe underscore B64 encode and payload JSON. And then we're going to dot decode it. And there's our separator. So we take in the encode, which turns it to UTF-8 bytes, I think. And so this is bytes object right here, and it converts it to base 64 bytes, which is a way that can be transferred over like HTTP and URL. And then it decodes it from bytes into a string. And then we separate it from the signature using a dot. And the signature is also a hex string. And then we will return the token. So I'll basically understand this now. Now we have def validate token, taking in token. So we're gonna try the payload in its 64 string version, and then the signature, which is also string. Its hex string format is equal to the token. We're going to split it, since it's a string. We use the split method on the dot, and then we're going to have payload bytes. So we're going to convert the payload to bytes from the string. So we say base 64 dot URL safe underscore B64 decode. And it's going to take in the payload 64 dot encode. So we're encoding the payload 64 string to be 64 base 64 bytes, and then we're decoding it from bytes to back to a JSON string. I think so. Converts back to JSONified string. URLC variant often from JWTs or APIs, and code converts it from a Python string to bytes, which base64 decoding requires. Oh no, it just converts it back to... Okay, it converts it... I'm sorry, yeah, I skipped it a step. It converts it from base64 bytes to regular bytes. Gotcha. I see. Bro, how to get my name, dog? What the fuck? What the fuck? Why would it do that, bro? How did you know my name was Josh, dude? What the fuck? Anyway, so this converts it back to bytes, raw bytes. Okay. And then we have the expected signature, which is going to be hmac.new. We pass in the secret key again. We pass in the payload bytes, which is the payload that we received. And then we're going to do #lib .sha256 sha and .hex digest. So this is the same line again. So hmac new, taking secret key, the payload bytes, and then the 6 hex digest. Okay. And then, if not hmac compare digest, return none. I don't like how they structured that. If not. If not is the same as saying if it's equal to false. Is if not same as saying if x equal to false. If not x is not always the same as if x is equal to false. This checks whether x is falsy, which includes false, none, 0, empty string, empty containers. So this will be true for any falsy value, not just false. I don't really like that. I'm not gonna lie. I don't know why. It just seems not specific enough. It only checks if it's literally the Boolean false. Okay. Well then that means what does hmac compare digest return? That's what's important, huh? takes A, B, used to safely compare two values, typically cryptographic values like hashes or HMACs. Is not timing safe and I can sometimes detect difference in processing time and guess the value byte by byte. That's crazy shit. What? Wait, what? Wait, what do you mean? The fuck? So they could, like, monitor the comparison, and if the comparison was false, they could, like, fix it. I don't know, that seems like, what? Anyway, compared to just uses constant time comparison to prevent timing attacks. Syntax rather than import HMAC. HMAC compare digest AB. A and B can be bytes recommended for cryptographic string. Must be both strings or both bytes. Okay, what does it return? Vulnerable to timing attacks. It's critical for cryptographic and secure comparisons. Does it return anything? Tell more about timing attacks. Yes, it returns a boolean. Okay, so it returns true or false. Right. Alright. Timing attack is a type of side channel attack where an attacker tries to learn sensitive information like passwords, crypto keys, or tokens by measuring how long operations take to run. The vulnerability. If you compare values like this, secret value is equal to user input. Python compares byte by byte and stops at the first mismatch. Oh, so they could brute force. Oh, ABC versus AXC. This leaks timing differences. That's insane, dude. How a timing attack works. Attacker sends many guesses, one character at a time. Measures how long each guess takes. Longer time equals more correct characters. What the fuck? Did you guys know that was a thing? I didn't know. That's crazy. Over time, they reconstruct the entire value in HMAC, password, or secret token. This especially matters with API key comparisons. HMAC or GWT signature validation, password verification. HMAC compare digest to the rescue. It prevents timing attacks by always comparing all bytes. Taking the same amount of time regardless of... Okay. HMAC compare digest. Well, that's cool. Damn, I learned something new. Okay. Indeed. So always use HMAC compare digest to compare HMAC hashes. Use the secure version anytime you compare secrets. Even if you want to simulate timing attack. List notable timing attacks. I just want to know, like, did this really happen? Some famous, some subtle. SSH timing attack 2003. The SSH protocol responded slightly faster if a guessed password character was correct. Remote attacker could recover valid usernames and brute force passwords after using response time. TLS timing attack. That's insane, dude. Discovered by Nadim L. Faradan and Kenny Patterson. TLS, SSL successor, padding validation leaked timing differences, allowing decryption of encrypted data. Affected Open SSL, Polar SSL, new TLS, allowing decryption of secure HTTPS under traffic under certain conditions. HMAC comparison in web APIs. Many web apps use equal to compare HMAC signatures in tokens or webhook messages. Attackers use precise timing tools to guess correct HMAC values by byte. Webhooks. HMAC signatures and token or webhook messages. See any GitHub webhooks, Stripe, Slack, and many JWT related middleware. JavaScript crypto timing in browser. JavaScript crypto timing in browsers, Spectre related. JavaScript's access to high resolution timers enabled timing attacks on memory caches, allowing leakage of secret data via Spectre and meltdown vulnerabilities. Major browsers, Chrome, Firefox, had to disable or reduce timer resolution in JavaScript. Password comparison and login forms. That's crazy. Anyway. Cool. Okay. Moving on. Expected signature, and then we just will say if expected signature is not equal to signature, so then we want to return the JSON loads. So then we convert the JSON, the payload bytes back to JSON. If expected signature is not equal to signature, return JSON loads, payload bytes. That's not right. If it's equal to, if it is equal to, if they match, converts payload to original dict, right? And like, do we need the separators? Well, it's only internally used. It's not even for visual, so like I don't think it matters. As long as the key and the value like match, the spaces just don't matter. Okay, so we should be good on that. Return JSON loads, payload bytes, converts payload to original dictionary. Okay. And then else will return if they don't match. Implies tampering or some other flaw. And what do we return in that case? Well, I guess we'll just return a string that says expected signature doesn't match signature. So how would that work exactly? They would go to validate the token, and then it would return expected signature to the match signature. I guess so. This would return. If they did match, it would return the original payload, right? So if it doesn't return a dictionary, then that means something went wrong, basically. Right? So we'll have accept, and we'll just we'll do okay. I think that's good. So they have to save this token. Yeah, the client needs to save. I gotta use the restroom real quick. Alright, I'm back. Okay, so I think this code is good to go, guys. I want to say this is good to go. Well, let's see. So now we would go over here and we'll import. You get this little div here. So what we're going to do is go over to the server and we're going to import this. Okay, I see. So basically, we're not gonna use this anymore. We're not gonna convert we're not gonna convert it to a string and stuff. Um, Okay, so that's it. Progress decent, not great. Honestly, it's okay. Took a while. Learning more about tokens. Create the hash token. Figuring out if we need to like have it in that proper final format before we encode it to send over the network. To make sure it's like, we're not like decoding, encoding, decoding, whatever. Like we're doing it right instead of some gobbledygook switching back and forth. I want to make sure I got it nice and clean. So we're gonna work on that when we come back. I'm gonna go to the gym, and take a shower, and yeah, we'll do another session. So I'll be back in just